This is the worksheet C, covalent bond between two atoms simulation, and first we are going to adjust as described for the hydrogen molecule H2. So we're going to do adjustable attraction and small diameter, and we'll put this attraction 3/4 of the way between weak and strong, and separate the moving atom to about here, and watch what happens. Now we're going to put the moving atom closer to the pinned atom. And now we're going to move the movable atom to a higher potential energy. Go. And then we're going to move this to the right. There it goes. Alright, so we are going to now do the helium to helium interaction. Obviously there are a bunch of questions for you to answer off of what you just saw, so make sure you do that. Pause the video to answer those questions, and then when you're ready for the helium-helium interaction, restart it. So we're changing the interaction strength to weak for this case, keeping the atom diameter the same, and pulling the moving atom to the right. We'll try moving it a little bit further to the right. A little bit further. Alright, and then we are going to push the moving atom close to the pinned atom and release. Close, release. We lost her. Close. Right, and so you can pause the simulation and pause the video and answer the questions. And then we'll move on to the fluorine sample, fluorine questions whenever you're ready. So we're setting the atom diameter to halfway between large and small, and strength of interaction to 1/4 of the distance from small to large. Or weak to strong, sorry. It's about 1/4. Alright. And let's move the fluorine atom. Okay, so now we're going to move on to the neon-neon interaction. And select neon. Look at the curve here. And let's move the moving atom toward the pinned atom. See what happens. Closer. And next we'll move on to the argon-argon. And we're going to move this towards, move it away and towards. Closer. And next we'll do oxygen. Doesn't really tell us to move this around, but we will. Alright, and then lastly we're going to the carbon monoxide molecule, which we will do adjustable attraction. Atom diameter is small, and interaction strength is strong. So there's the CO. So we're supposed to notice the bond length between the atoms, and we're going to flip back to oxygen so you can compare what that looks like in comparison. So going down to this, and strong versus the oxygen. Right, and then we'll go back to the carbon monoxide. So again, small diameter, strong interaction. Right, and let's see what happens here. So this is supposed to be the carbon monoxide. And we want to compare this to fluorine as well. So we have the atom diameter like this, and strength like this. So that's supposed to be the fluorine again. And then comparing that to oxygen one last time. Alright, and that should be it. If you want to replay anything, please do so.